expand to simple logs. Where's our starting point? You want to work on this for a minute, or you want us to work on it together?
I don't care. We get on. Go through this one again and then the next one.
Very good.
So is the starting point to put everything inside of brackets with 1/2 on the outside?
Yes. So first I have to remove this. So removing the power means square root, which means 1/2. So 1/2 goes in front. Log of x squared plus 4 over x squared plus 1 and x cubed minus 7 squared. That is the starting point, because that square root is in the way. Very good. Now the next step. I will leave 1/2 outside. And what do we have in brackets?
Split the top and the bottom of it.
Right, so I have log.
X squared plus log 4.
I cannot,
Sorry.
be very careful.
Right.
We cannot, there is no property that allows us to change log of a sum into anything.
Okay.
We only have 3 properties. Log applied to a product, log applied to a ratio, and log applied to a power. And then,
Minus log of x squared plus 1. Minus
exactly.
log. Or
And
2,
I will put the 2.
Yeah, 2 log x cubed minus 7. And that would be it because everything has a variable.
Exactly. The only final step that I still have to perform is distributing 1/2 to all 3 terms.
Right.
Nothing else is required here.
So you don't want to leave it outside.
No, because I don't want to leave brackets.
Okay.
I don't want any brackets left in the problem. So 1/2 log x squared plus 4 minus 1/2 log x squared plus 1 minus, there is a 2 in front and there is a 1/2, so this is only minus log x to the 3rd minus 7. And this is it. Okay, next problem. Next problem with, yes, Nico?
So even though the bottom, the denominator, x squared plus 1 times x to the 3rd minus 7 squared, even though those are multiplied by each other, it's still minus because they're below.
Here's why, because then you have log of this minus log of this product.
Yeah.
But then you have to distribute the negative sign,
Okay. Yeah.
because then you will change this into log of this plus log of this, but there is a minus in front. So instead of maybe forgetting that, always look at the problem and say 2 quantities in the bottom, 2 quantities will have negative in front. 1 quantity at the top, 1 will have positive in front. Because otherwise you will have to do it in more steps and you may forget to distribute negative 1. See, if I make the mistake and put a plus here, then I'm really telling you that this quantity is at the top, but it's not. This quantity does not come from the top of the fraction, it comes from the bottom. So the positive will be wrong. Is that okay?
Yeah.
Okay, good. Next problem. Anything else? Anything else here? You wanted to choose another for condensing, right?
Yeah.
Do we still want a condensing?
Yeah, there's
Okay. There must be one in here as well in the test. So there is an expanding right here. I did not put a condensing per se because it's in a log equation already. But let's do one. Yeah, it's basically here.
52.
52, same page, right? 52. So 2,
Oh, we already did that. I don't know.
we did?
No, I think that was on a different section.
Okay, 2
Yeah, that was
Log-
5.
log base 5 of x plus 2 log base 5 of y and minus 3 log base 5 of z. Okay, do we do this together or you want to work on it for a moment?
They work on it for a moment.
Okay. Do we need more time? Okay? Yes? Okay, where's the starting point?
Inside.
Yes, absolutely. And where will it be?
Separating the plus and minus of the numerator and denominator.
True, but here's my starting point right here.
Oh, okay, yeah,
So I have to worry about these numbers first.
I combine.
So I have to clean this up the inside. So I have 2 the outside, log base 5 of x plus log base 5 of y squared minus log base 5 of z to the third.
Yep.
Now plus, these quantities will come from the top.
Yes.
A minus, this will come from the bottom.
Right.
And then I'll take care of this.
Yeah, right.
Good. So then I have 2 log base 5 of x y squared over z cubed.
And then everything squared.
And everything squared inside here. So then I have log base 5 of x squared y to the 4th z to the 6th. Copy the base, multiply the exponents.
I distributed the 2 first,
That's fine.
and then
That's fine. Always remember, keep the constants waiting. That's my theory. They mess me up. They make the problem more complicated. Okay, anything else from anything else? Okay, so let's look through the test. Is there anything else from last time that you would like to go back to? Okay, so let's look through the test and say yay or nay. For example, if you ask me which problems I think are more involving, I can tell you. This one. This one. They require more time. Both of them. This one is not a big deal. Problem 6 is not a big deal, I would say. We'll do anything you want. Problem 7, it will take a while because I have to think on number 7. It's just not 100% routine. Yes, number 8, because I have sine 2x and I have cosine 2x, and cosine x over 2, and it requires some time. I have to think, I have to remember formulas, identities. So, okay, this one we already did last time. Now this one I don't think it's going to be any difficulty. Problem 10. Now this one requires time because it's a trig equation. first I have to factor, then I have to solve for cosine, then I have to go back to the unit circle, then I have to find the reference angle, then I have to remember what it is, then I have to think in terms of 2 pi k, blah, blah, blah. So this is not a trivial situation. There's a lot of steps. I'm sorry? 11.
Number 11, would that be a quadratic form?
Yes.
Which
No, no, it's not quadratic in 4. You have to factor it.
Oh,
It's not quadratic in 4 because of the 2,
oh, okay.
right? So, this one, not too much. This one requires some time because, again, I have to remember the formula, I have to put it in, I have to square, I have to be careful how I distribute, blah, blah, blah. Okay, and here's another, a trig equation that requires time. First of all, I see both sine and cosine in there. I definitely have to get rid of one or the other. I can't solve a trig equation with 2 different trig functions in it. I have to reduce it to 1 somehow. So, yes, what would you like to start with? I would like to be able, if possible, to finish this in roughly about an hour so I can show you what I...
Can we do number 4?
Number 4. Let's start with number 4. Yes. Yeah, number 4 is, again, requires some algebraic maturity by now. Natural log x minus 1 over 2 minus x. The question is only asking us to find the domain. So, where is the starting point? What do I have to write? Yes, that's the restriction that I have to write on natural log. Correct. What do I have to write? Yes?
X minus 1 over 2 minus x should be greater than 0.
Awesome. That is the only thing I have to write. Good. But now I have to dig deep and ask myself, okay, what is this?
Rational.
It's a rational inequality. Awesome. And then I have to think again and say, okay, how do I solve a rational inequality? Because I'm not allowed to multiply. So there must be something else I have to do here.
Sure.
Exactly. Exactly. Yep, our hands are tight on this one. We can't separate anything, we can multiply, we cannot simplify, we cannot do anything. I'm happy that it's chart ready, but there is nothing else I can do. So from negative infinity to infinity, very good, awesome. And you have to be very careful. This is in the correct order, but this one is not. So this should be written as negative x plus 2 so I don't make a mistake when I establish the sign.
Did you also just write x minus 2?
Say it again.
X minus 2? Did you write that also?
No. I can't.
Okay.
Unless you want to simplify. You could rearrange it, factor out negative 1, and then multiply both sides by negative 1. Otherwise, I cannot write x minus 2.
Okay.
Because I have to study the expressions as they are. Unless, which is fine if you do that, unless I'll say, I don't like the way it is arranged. I'm going to do this. Then I'm going to put a minus in front, because I'm allowed to.
Yeah.
And then multiply both sides by negative 1, and then I get this. Then I agree.
Okay.
But you cannot put it as a third row or change this one into x minus 2.
Okay.
you can change this into this. That is allowed because they are identical. But I cannot change this into x minus 2 because they will not be identical.
Is that just because the variable comes second? It comes after the 2.
Yes,
Right.
yes. And because I may be tempted to say, oh, it's 2 minus x. Oh, it's got positive slope. But it's not positive slope.
Okay.
So what numbers go in the chart?
1.
Exactly. So 0 and 0. What happens to the ratio under 1?
0.
Very good. What happens to the ratio under 2?
Undefined.
Thank you very much. Very good. So now the sign for x minus 1.
Negative to positive.
Very good, because it's a positive slope. And for the other one?
Positive to negative.
Correct, because it's a negative slope. On the first subinterval, the sign is?
Negative.
Very good. In the middle, the sign is?
Positive.
And outside, on the other side? So since we did not work on this, and we worked on this, I have to choose which sign.
It's greater than 0.
Good,
Between 1 and 2.
between 1 and 2. So domain for this function is 1, comma 2. Although not a huge deal, it required a lot of thinking.
Yeah.
It was not just a routine type of problem. Okay, so we can check that off. Next, what would you like?
Maybe 5A.
5A. Yes. 5A is not a difficult problem.
Right.
However, it has a lot of steps, and you have to be careful. 4 raised to 1 minus x equals 3 raised to 2x plus 5. You want to work on this for a minute, or you want us to work on it together? You choose. We work on it together? Yeah?
Sure. Yeah.
Okay, very good. So what is this?
Proportion. Exponential.
Exponential, very good. So can I make both sides with the same base?
No.
No. So what is my only chance?
Log.
Any log, but the same log.
Yeah.
It doesn't matter which one. It can be natural log or it can be common log, but it has to be the same to both sides. So, because remember the concept. The concept is this. Two numbers are equal. Their logs will be equal.
Yeah.
But it has to be the same base. So which one you prefer?
Natural log is fine. And 1 minus 2.
So two numbers are equal. Their logs will be equal. That's a one-to-one function. Good. So now what do I have to write as the next step?
Parentheses.
Yes.
1 minus x plus parentheses.
Perfect. Well done. Equals?
Parentheses 2x plus 5.
All I have to do now, this is basically linear equation. It's not a big deal. I have to distribute those numbers to these two terms, this here and this here, move terms around, and solve for x. So natural log 4 minus x natural log 4 equals 2x natural log 3 plus 5 natural log 3. So these two have to be on one side, and these have to be on the same side. So I'm going to move this here. So natural log 4 minus 5 natural log 3 equals x natural log 4 plus 2x natural log 3. Now I'm asking myself, what do I do next? since I cannot combine like terms.
Factor out.
Yes, always remember factor, simplify. So in this case, I have to factor. And I'm factoring out x. So natural log 4 plus 2 natural log 3. And the final simplified form will be this over this. So natural log 4 minus 5 natural log 3, natural log 4 plus 2 natural log 3. Now, I know you understand if you're trying to simplify this expression by simplifying natural log 4 with natural log 4 and natural log, that would be a terrible mistake. Because you cannot simplify terms, right?
Right.
So now the only thing you can do is plug in the calculator, get an approximation, and then go back and check. I will definitely do that if I have time, because it's very easy to make a mistake here. So first let's find an approximation of this, and then what I'm going to do is change like we did today, change this equation into move this term to the left-hand side. So I'm checking this. If I'm checking this instead of the original equation, which they are the same, then I can recall the previous answer and put it in here. If I separate these two and I determine a value for each separately, then I will not be able to use this in one step. So I highly recommend that. So parentheses for the top. Parentheses, natural log 4 minus 5 natural log 3. Divided by parentheses, natural log 4. Plus 2 natural log 3. Once I get this number, in the next step I would write 4 caret in parentheses 1 minus the previous answer, close the parenthesis, come down, minus 3 raised to, in parentheses 2 times the previous answer, and plus, what was it, plus 5. So now if this is the correct answer, negative 1.146,
Get 0.
I should get 0. So then I can say that this is indeed negative 1.146. Any questions here? Okay, anything else? Anything else appeals to you? Of course, we don't have to finish this actually today. I mean, we have Monday and Wednesday next week, but it's up to you. Yes. Very good. Let's do 8. And we are asked to find sine 2x. We're asked to find cosine x over 2. And the quadrant in which 2x and x over 2 have their terminal side. Given that, we are only given that cosine x is 3/5, and x is in between 270 degrees and 360 degrees. Which quadrant is that?
4.
Very good. If I'm given that x is in the 4th quadrant and I'm told that cosine is 3/5, can I determine sine? What sign will sine have in the 4th quadrant?
Yeah.
Very good. So then I have sine x equals negative the square root of 1 minus cosine squared. Or you use the triangle. It doesn't matter. That's fine. So I'll put it in here. So this is negative, but be very careful with the sign. Okay. So it's 1 minus 9 divided by 25. 25 minus 9 is 16. So negative 4 over 5. So I have sine and cosine. And I can already answer this because the formula or the identity for sine twice x is 2 sine x cosine x. And I have both. I have sine, which is negative 4/5. And I have cosine, which is 3/5. And when I multiply, I get negative 12. I'm sorry. That's negative 24 over 25. I'm asked to find the quadrant for twice x. In order to find the quadrant for twice x, I have to also find cosine twice x. I won't be able to simply multiply both sides by 2 here and find the quadrant for twice x. It's not going to happen. But since I have sine twice x, I can determine cosine twice x very easily. And if this is positive, negative and positive will be the fourth. If this is negative, negative and negative will be the third. So these are the options. So cosine twice x has 3 formulas. But since I'm given cosine, I will refer back to the one that is 2 cosine squared minus 1, in which I will plug in 3/5. So this is 2, 3/5, 9 over 25 minus 1. So this is 18 minus 25 over 25, negative 7 over 25. Since sine twice x is negative and cosine twice x is negative, I know where 2x is. 2x in which quadrant? That's it. So for double angle, I don't have a way of determining from x, I don't have a way of determining the quadrant. But if I determine sine and cosine for that angle, there is no secret. There is only one quadrant in which sine and cosine are negative. So,
Okay, so why did we do cosine 2x again?
to find the quadrant for 2x.
For sine 2x.
For the angle 2x.
Okay.
So we found sine and cosine in order to find the quadrant for the angle 2x.
What does sine 2x give us in that sense? If cosine 2x gives us the quadrant.
No, sine and cosine will give us the quadrant.
Oh.
So the question first,
Because sine and cosine are both negative, then we know it's in quadrant. Oh, I get it. Okay.
we were asked to find sine twice x. We were not asked to find cosine twice x.
Right.
But without finding cosine twice x, I will not be able to establish the quadrant.
Okay.
I can say there's definitely 3 or 4, but which one, I don't know.
Yeah.
But once I find that cosine twice x is negative, then I know for sure it must be in the third quadrant
For twice.
for twice x.
Okay.
Okay. So we're still going to do cosine x to 2, right?
Yes, I didn't get to that yet. So now for x over 2, I can determine the quadrant from here. I don't have to find sine x over 2.
Right.
And here, yes, dividing by 2 is okay. But multiplying by 2, I get such a wide range that I don't know which quadrant it is.
Okay.
That's why I didn't even attempt to multiply both sides by 2 to find the quadrant. But I can divide both sides by 2, and I will be able to establish the quadrant for x over 2. And then I'll find cosine x over 2. So 270 degrees less than x less than 360. I divide both sides by 2, 135 degrees, x over 2 less than 180. And this is specifically only one quadrant. Which quadrant is that for x over 2?
2.
That's it. There's no ambiguity. And now I can only determine, I only need to determine cosine x over 2. So cosine x over 2. Since x over 2 is in the second quadrant, cosine x over 2 will be positive or negative? Very good. Negative. The square root of 1 plus cosine x over 2.
So which,
The half angle identity.
no, I know that, what I'm saying, so which ones do we have to double angle and half angle?
Which one you have to remember?
Yeah, for the test.
Half angle, double angle, sum, all the co-function identities. We listed them last, I think it was last time or the time before.
Yeah.
I can look it up if
At
you,
the beginning of the day. you
yes,
Put them all, yeah.
that list.
Yeah, it's like everything.
Except sum to product and product to sum. And except tangent x over 2, those 3 formulas that I said that would be given to you. Okay, so now all I have to do is just replace cosine by 3/5. And it's done. 1 plus 3/5 divided by 2, negative. So 3 plus 5 is 8. So the top is 8/5 and the bottom is 2 over 1. I have to flip. So negative 8 over 5 times 1 over 2. So it's negative 2 over the square root of 5, and I will rationalize. Good, next question. You want to look at trig equations? You want to look at lowering the power? Which one?
11.
You said 11? Very good, 11. So 2 cosine square minus cosine x minus 1. Good. Again, same questions all over again. What is this? It's a, yes, I completely agree. Combined with, yes, yes, I completely agree. It's a trig equation because the variable is basically cosine, first of all. And it's quadratic because it's quadratic in cosine. Very good. So perfect identification. And now what do I do? I have to factor it. Yes. Absolutely. I have to factor it. Question is, how do I factor it?
2 cosine x
Very good.
plus 1
Very good.
times cosine x minus 1.
Awesome. Let's check. 2 cosine times cosine. Negative 2 cosine x plus cosine x. Correct. 1 times negative 1. Negative 1. Correct. Perfect. So then there are 2 solutions in cosine x, because that's what I have to do first. I have to solve for cosine x. So this is an equation with 2 levels actually. One level is I have to solve for cosine, and when I'm done solving for cosine, then I have to solve for x. So what are the 2 options for cosine?
Negative 1/2
Yes,
and 1.
yes. Do you agree with cosine being negative 1/2 and cosine being 1?
Yes.
Okay, let's start with the easier one.
Wait. Just run through how you got
Move 1 to the other side, divided by 2.
that. Oh.
Move one to the other side,
I
1.
thought we were just doing cosine.
No,
Okay.
no. First we have to solve for cosine. Good. And now, let's start with cosine x equals 1. I have to go back to the unit circle. I have to ask myself, where is cosine 1? I know that cosine is measured on
X.
perfect. And where is cosine 1? Or 0. Good. So then x equals 0 plus 2 pi k. Or 2 pi k. But I still have to write k equals 0 plus or minus 1 plus or minus 2 and so on and so forth. And that is done. But now I have to solve the other one. Cosine x equals negative 1/2. Back to the unit circle. I have to find the quadrants in which cosine is negative first, before I even look at the number. Cosine is negative in which quadrants? Very good. Perfect. Now I have to think, okay, I need to find the reference angle, and the reference angle depends on the angle whose cosine is 1/2. Which angle has cosine 1/2? That is the top angle, and that is sine
I have a 3.
pi over 3. So 1, 2, right here. 1, 2, right here. This angle and this angle. So what is the reference angle in both cases? You already told me. Pi over 3. So therefore, there are 2 options. Well, infinitely many, but 2 distinct. X equals and x equals plus 2 pi k. Can anyone give us those 2 angles? One with the terminal side in the second quadrant and the other one with the terminal side in the third quadrant.
It's 2 pi over 3.
So I have pi minus pi over 3. Very good. 2 pi over 3.
4 pi over 3.
Yes. And pi plus pi over 3. 4 pi over 3. Very good. Is this clear how we got to 2 pi over 3?
Yeah.
Is it clear how we got to 4 pi over 3? One more time. Pi minus pi over 3. Pi plus pi over 3. And if you take it aside, pi minus pi over 3, 3 over 3 minus pi over 3 is 2 pi over 3. And if you take pi plus pi over 3, pi over 3, 3 pi over 3 plus pi over 3 is 4 pi over 3. That's it. Okay, anything else?
So we have to write full load.
Mandatory, yes. Anything else from this test for now? Anything else? Will you be able to finish this test between now and Monday so we can continue talking about it? Okay, good. So I would like to get back here, and I like to look at these. We're not going to be able to finish everything today, but at least if I could do the circle, the parabola, and the ellipse, that would be great. Since